Hello everyone, my name is Muhammad Reza Mahaki. Today I'm going to show you how my science can benefit soccer. Today I'm going to present how VO2max test influences biomechanical and physiological gait features in male soccer players and how the players can be optimally recovered after VO2max test. VO2max is considered to be the most important component of aerobic endurance performance. The higher VO2max, the longer and harder you can exercise for. It has been reported that VO2max greater than 60 milliliters per kilogram per minute are required to play in season matches in elite soccer players. Moreover, in some cases, team ranking could be explained by differences in VO2max. For this reason, professional soccer players are frequently examined by VO2max test. Incremental Exercise Test, or IET, is used to evaluate VO2max. IET includes progressive increases of the treadmill speed. Oxygen consumption, heart rate, and cardiovascular performance increases during IET. VO2max is determined when VO2 reach a plateau despite increased intensity. Therefore, IET generates a large post-exercise oxygen deficit and the releases of metabolites such as lactate. This metabolites makes inhibitory effect on alpha motor neurons and it influences musculoskeletal systems. These changes in body state are thought to be responsible for the gait stability disturbance. Previous studies reported that IET induces less stability and more variability during quiet standing and gait. IET also induces increased trunk flexion or a decreased trunk extension in running of novice runners. Based on the literature, we hypothesize that IET significantly increases energetic cost and gait variability alongside a significant reduction in gait stability in male soccer players. In high-level athletes, it is so important to recover fast in order to continue their training. However, it is not clear how soccer players can be optimally recovered after VO2max test. There is no consensus whether active or passive recovery are more active at post-IET. Active recovery means recovery by submaximal exercise. We use walking at preferred walking speed and running at individual ventilation threshold as the two active recovery modes. Another recovery mode that we use is passive recovery, which means recovery by resting. We use these three recovery modes and compare them to recognize which recovery mode is better to recover soccer player after VO2max test. Previous studies reported that active recovery induces faster recovery of blood lactate. It also induces faster recovery of cardiovascular and respiratory system. Therefore, we hypothesize that compared to passive recovery, active recovery modes significantly produce faster recovery in male soccer players. After system setup and participant preparation, we started our experimental conduction. As you can see in the flowchart of our study, we started data collection with measuring resting metabolic cost in the seated position for 5 minutes. After that, subjects walk on the treadmill with his preferred walking speed as his baseline. PreT, post 0, 1, 2, and 3 were the trial that we collected data and we analyzed the data. After PreT, subjects was submitted to the VO2max test. We increased the speed of the treadmill 2 kilometers per hour every 2 minutes, and we stopped the test when subject reached his VO2max. We had 3 recovery modes, and we chose one recovery in each session in a random order, running at individual ventilation threshold, walking at preferred walking speed, were our active recovery modes, and resting, which was the passive recovery. Our results show that energy cost was significantly increased by incremental exercise test. Gait variability was also significantly increased by IET. However, gait stability was not significantly influenced by IET. Therefore, our first hypothesis was partially supported by our results. In terms of gait variability and energetic cost, our results are in line with the results reported by previous studies. Both of them increased at post-IET. However, previous studies reported mixed results in terms of gait stability. Vera et al. Reported less stable gait pattern. Hemacher et al. 2016 reported more stable gait pattern, and Hemacher et al. 2018 reported no significant effect of IET on gait stability on young athletes. This discrepancy could be due to the level of participant activity between studies. For instance, male soccer players in our study and young athletes in the study of Hemacher et al. 2018 might have more higher core endurance, which helped them to be able to control trunk stability at post-IET than young healthy adults. Why IET increases gait variability and doesn't change gait stability in mild soccer players? The increase in gait variability might reflect accommodation of neuromuscular system to maintain local dynamic stability. Our results show that walking at preferred walking speed and rest as a passive recovery induce faster recovery than running at IBT in terms of energetic cost. No preference for active recovery over passive recovery was found in terms of energetic cost, gait variability, and stability. Therefore, our second hypothesis, active recovery mode, produces faster recovery than a passive recovery, was not supported by our results. Therefore, our results are in contrast with the results of previous studies in which they reported that active recovery induces faster recovery of blood lactate and induces faster recovery of cardiovascular performance. One reason of our results could be due to higher mechanical and physiological demands in active recovery than in passive recovery. However, our results are in line with the results of previous studies in which they reported that active recovery is largely ineffective in enhancing sport performance, is largely ineffective in enhancing the recovery of muscle soreness and neuromuscular function, and in the recovery of muscle glycogen storage. Our results also show that running at individual ventilation threshold produces higher energetic cost than walking at preferred walking speed and rest. One reason could be due to higher mechanical and physiological demands in running than in walking. In conclusion, soccer players were able to maintain their gait stability despite the increases in energy cost and gait variability after VO2 max test. Walking at preferred walking speed and rest are recommended for reducing energy cost at post-IET, and no preference for active recovery over passive recovery was found in terms of energy cost and gait variability.